pseudomonotony, which is also solutions to a fixed point problem on the demimetric mapping. Finally, we give some numerical example for supporting our main result, and also compare with some earlier announced method in the literature. And that is our abstract. So we proceeded to the introduction, in which we let us know what our H means. We define the Hilbert space, fractional inequality problems, and we make some little citation. So from our introduction, we say let H be a real Hilbert space with inner product and the norm of this. Let C be non-empty closed and complex subset of the real Hilbert space H. The fractional inequality problem for an operator A is primarily to find a point X star into C, such that. So that is the definition of the fractional inequality problem. So, and the solution set of this one, we define it, and we show the donation for the fractional inequality problem. So we talk about the past work of our researchers. We define the Seng extragradient method, which is in 1.2. We also, sir?
Seng, how is 1.2 Seng?
Okay.
Gradient method.
And which is wrong. You can't use this method to solve relational inequality. It's not possible. Or wrong. Any method that you are going to use to solve a relational inequality has to be associated with the projection operator. So 1.2 has no projection operator, so it's not possible. There's nothing like gradient method for relational inequality. It is rather projected gradient method. It is PC of xn minus alpha gradient of f of xn. So that's the method that is used. And this method that you're seeing here, that is even used for solving minimization problem, not relational inequality. It says solving this VIP problem was started with the gradient method introduced in 5. So if you're looking at gradient method, then this has to be PC of xn minus alpha axn, not xn minus alpha gradient of f. Gradient of f is this is exploring the relationship, the formulation of relational inequality as a minimization problem. So this is not a minimization problem. Minimization problem, nothing what the y dx. So there's nothing gradient here. The gradient, what you call this gradient now, is the equivalent or the mapping A itself, that cost operator. So that should have been PC of xn minus alpha A of xn. So that's wrong. 1.2 is wrong. I don't want you to go more forward before I mention anything again. So that is wrong. 1.2 is wrong.
Okay.
Please, Edo.
It should be PC of xn minus alpha axn.
PC of xn minus alpha xn.
Axn, it's gradient of f1 and capital A. And the PC, you cannot solve a relational equality without having the PC. You can hold on. Let me quickly show you something. Stop. Just stop sharing and let me show you. Mo rántí pé mo mention nígbà tá a bẹ̀rẹ̀ kí lorúkọ ẹ̀ nígbà tá a ń ṣe class yẹn, and then we saw the relationship between the both. So you better on the screen, are we?
Yes, sir. Yes.
Okay. Now, look at this. The fixed point problem consists of finding a point x in C such that x is tx, right? Where t from C to C is a given function. To express the rational inequality problem, I'm supposed to put
Hello,
as
hello,
a
sir.
fixed point problem.
Ṣé mi nìkan
Yes.
ni mi ò mọ rí screen kankan? Àbí? Okay, mo ṣe rí. Sorry.
Here,
Mo ṣe
to
rí
express
screen mi ò rí screen.
it's all right. To express the rational inequality problem as a fixed point, that's what I'm supposed to have put here. As a fixed point problem, one needs to apply the projection mapping, also called the what? The direct point mapping, you see. So this is very, very key. This is very, very key. To express this as a fixed point problem is very, very key. And look at the okay, it's just that definition that I give afterwards. So this PC is very, very important. It's very, very important. So that is missing in what you call that. So the method rather is for solving minimization problem. That method is for minimizing, not for racial inequality. Though there is a relationship between both, can formulate racial inequality as a minimization problem. So you can go ahead. So play Dr. Aluko.
Thank you, Doctor. Well noted. So, can you hear me, please?
Yes.
Yes, we can hear you.
Okay, sir. So
You
I
can
think
move to the next paragraph.
can you move to the next
Move to the
paragraph?
next paragraph. Yes, move to the next paragraph.
The next one.
Hold
Yes.
on. Ẹ jẹ́ ká tún bẹ̀ yẹn kà. Ẹ jẹ́ ká tún bẹ̀ yẹn kà. I want to read it by myself. Just take it back to that side. Ẹ má bínú. I want to see something there. Okay. They say solving this VIP problem was started with the gradient method introduced in what? In 5. Okay. Now let's say 5. The author formulated gradient method as follows, where alpha is a step size, and look at that and that is ans. Let's type in man. And ans is gradient f of x and is the gradient of the function f. A modification of the gradient method was done by Gostein. Introduced a projected, okay. You see the reason why I said we should go back on it. He says the next sentence is that he introduced a projected gradient method for solving VIPs. The way you have presented that thing, logic code 1.2 gangan solution.
Yes.
The way you have presented.
Yes.
So
Yes.
the next sentence already indicates what the solution method is. You can see that I mentioned that it should be a projected gradient method instead.
Yes.
You see, the next sentence says a modification of the gradient method was done by Gostein 9. It should be Koyeko Pari Kefi full stop. So where he introduced, it should have been where he introduced a projected. Do you understand what? Do you understand? So maybe like a modification of this was done by Gostein 9, where he introduced a projected gradient method for solving VIPs. Then which improves solving the VIP, that does not make sense. It's not a part of it. Sorry, that's not a part of it. Which improves solving? No, that's not a part of it. But the statement from the beginning, solving this VIP was started with the gradient method. Am I wrong? So we better get to be part here. So that side will be wrong. It should have been. It is based on. Even if at all you're going to introduce the 1.2, method Tafelugogo are based on the 1.2, and it's not the 1.2 that is used.
Yes, you're on track, sir.
So mi ò mọ̀ mo ìfẹ́ sọ́nà nǹkan tó wrong bẹ́ẹ̀ náà nìyẹn. Nǹkan tó correct wà níwájú. Nǹkan tó correct wà níwájú ẹ̀. But bẹ́ẹ̀ ṣe present ẹ̀ láti bẹ̀rẹ̀ wrong. Yeah. So 1.2 gangan core is not, it's not 1.2. Yeah, it's 1.2. This it's like báwo ni kí n ṣe pè ní, is it an extension of what?
Sorry,
Bọ́ ẹ pè ní mo.
Dr. Yewale, sorry.
Yes, sir.
Nǹkan tí 1.2 yẹn fi wọlé ni pé ṣé ẹ̀ pé every method after graded method ló dàbí pé graded method yẹn after the learning projected after the learning extra graded, so we must start from the origin then ká wá máa sọ̀kan tí others ṣe lórí ẹ̀, that is the essence of that, but ìdí ẹ̀ ní 1.2 fi wà bẹ́ẹ̀ anyway. Àfẹ́ máa
But
dárúkọ nǹkan
ó wrong báyẹn. Ó wrong
That
báyẹn.
1.2 is not a graded method. Hold on.
Kò bẹ̀rẹ̀ pẹ̀lú
mo ti
1.2 rárá.
understand
Kò
yẹn.
bẹ̀rẹ̀ pẹ̀lú 1.2. Ó bẹ̀rẹ̀ pẹ̀lú ghost time yìí gangan ni. Sẹ́rí nǹkan tó ṣẹlẹ̀ ni pé báyìí ni ẹ get it right. Ẹ jẹ́ kí n lo kíní again. It's good that we can learn from that. Ń bọ̀, ẹ fún mi 1 minute. Ń bọ̀, mo ń try láti connect kíní mi o. N tí máa fi kọ, yeah. Okay. Rí whiteboard mi.
Àti rẹ̀.
Yes.
Dr. Ogunṣọlá máa pẹ́ kó tó rí kíní làwọn ń lò. Analog.
This way.
Now, a point X is a solution to the minimization problem or minimize f of x in Rn if and only if x is a solution to the VIP gradient of f of x, comma, y minus x equals greater than or equal to 0. To be kíní lélẹ̀, for all y in Rn. Variational inequality, àbí?
Yes.
Yes.
Yes, sir.
So, establish relationship to an variational inequality at the minimization problem. Now, let's say x is a solution to the minimization problem. Shall we, if and only if no, I've got to prove two sides. Now, let x be a solution to the minimization problem. Then let x be a minimizer of f. That's what it means, being a solution to the solution to the minimization problem. That is, it's a minimizer of f. Then define a function. Suppose g of t, for instance, is equal to f of y plus f of x rather plus t into y minus x. Since C is a now we're using Rn. Rn is a convex space. It's a convex set. So if it's a convex set, and this is a convex combination of x and y, x plus t into y minus x is the same thing as saying 1 minus t into x plus ty. So, because you have to learn later to so this will also be in the solution set now for all t in 0, 1. Okay. Now, since g time will attain minimum at t is equal to 0. Since g attains its minimum, minimum function, dy dx is equal to then we set it to 0.
Yes.
Our final function, for instance, g is equal to 2x squared plus 3. I want to minimum of this function. The first thing we're going to do is to find the g dx, which will be 4x plus 3. Then what do? We set it equal to 0 and say x. So that's the point where with this function attain its minimum. Now, since g attain its own minimum at 0, it's defined on this. So g attains the minimum at this. So you say 0 will be less than or equal to g prime of 0. Which is equal to, now let's find the derivative of this function. The derivative of this function is going to be gradient of x plus c into y minus x multiplied by, differentiate what's this thing is going to give us y minus x. Is that not? Y minus x. Yeah. Now, but at t is equal to 0. Now this is g prime now. G prime of t. But t is equal to 0. Gradient of f of x, right? Multiplied by y minus x. So which is also the same thing as saying the inner product of f of x, comma, y minus x. And recall, we have said 0 is less than this. So which means gradient of f of x is this is greater than or equal to 0. So which means x to the minimizer solution. With the solution that we've already established that x being a minimizer is a solution to this. Okay. Feed the other side left. Let me quickly go through the other side. That is, if x solves the variational equality, then x is a minimizer. Now, assume on the other hand, assume that x is a solution to the VIP. Let's put it this way. Sorry, x, not x bar, of Rn, comma, gradient of f. X is a solution. So, and f is convex. So by f being convex, we mean f of y will be greater than or equal to f of x plus gradient of f, comma, y minus x. So to replace x is convex function, we must satisfy Kimi. Now, x being a solution to this, what does it tell us? Also, no, this is of x. Also, this part will be greater than 0. Is that not? So if that is greater than 0, we mean f of y will be greater than f of x. So that is f of x is less than f of y. So that means x is the minimum of the function. F of x is less than f of y. Y is arbitrary, so x is the minimum. So x being a solution to this implies x is a minimum of the function. So we have already proven that if x is a minimizer of a function, then f solves a variational equality with the function being the gradient of the what? With the function being the gradient of the function itself. We must solve variational equality with this as a function, as a cost mapping. So then another one, x is a solution to the VIP if and only if x is the fixed point of the mapping PC into I minus lambda A, where lambda is greater than 0. You can see it's the fixed point of this. That's why any solution for operational equality has to include what? Has to include the PC. Has to include the PC. So method xn plus 1 will only solve this. It will solve the minimization problem. This minimization problem we must solve. That is, find x such that f of x is less than or equal to f of y for all y. You're not going minimization problem. Until mo collect minimize f of x in clinical, it's the same thing as writing it this way. Kò sí yàtọ̀ nínú òkè yẹn. Kò sí yàtọ̀ nínú eléyìí nǹkan tí mo kọ́ ń bì àti f of x is less than or equal to f of y for all y. So there's no difference. So any solution method. Now, tí mo wá lọ bẹ̀ ni pé method tẹ kọ́ yẹn gangan fúnra lára rẹ̀, ó ná improve àbí ná extend only method fún minimization problem, just like we have written it, is this. All right. Now, but for variational inequality, you have to include PC. So which is now going to be this minus alpha A of f of x. Gbogbo gradient a máa sọ ilé náà là ń refer as gradient. This A. Ẹ máa rí pé position gradient of f yìí ló take nínú kíní. So that's why that
Yes.
first method is called projected gradient method. Projected gradient method, because it involves now a projection. So this is the method Goldstein introduces. Then the next one, only extra gradient, because òun ti require evaluation a yẹn lẹ́ẹ̀mejì, axn yn is equal to this. Then xn plus 1 is now pc into xn minus alpha ayn. You can see that it requires the evaluation of the operator a twice. Can you see? So
Yes.
eléyìí ló ṣe ń jẹ́ extra. So but ibi tó ti bẹ̀rẹ̀ rí, it started with the solution method started with the projected gradient method. Ẹ má bínú pé jọ mi kọ, mo kàn fẹ́ ká clear ibi ibẹ̀ yẹn so that ẹ má lè put side yẹn dáadáa.
All right.
Ṣé Dr. Aluko get mi báyìí? Mi ò rò wọ́n wà bẹ́ẹ̀ o.
Wọ́n wá ń bẹ̀. Ọ̀dà àbọ̀n ti kúrò.
Wọ́n wà mo ń rí 6 tàbí báwo. Àbí ok ṣé 7 ló yẹ ká jẹ́ tó máa wà bẹ́ẹ̀.
Ọmọ Absor ti fi fóònù tiẹ̀ náà join.
Ok, àwọn náà sí bẹ́ẹ̀. Dr. Aluko sí bẹ́ẹ̀. But explanation mi clear ṣá.
Yes. Yes.
Naam.
Má bínú o, nǹkan tí mo fẹ́ lọ
Mr.
present
Kajola.
lọ́la ní Sefako yẹn.
Mr. Kajola,
No.
nǹkan tí wọ́n ṣàlàyé ẹ̀ ṣó yé yín dáadáa.
Yeah.
All right. So because mo network mi ń lọ ń padà ní, so mo dẹ̀ rí pé other.
Ó wà recorded anyway.
Yes, so we can listen to it again.
Mhm.
So can we continue now?
Yes.
So, however, when the assumption of the cost operator is weakening to the monotone, the PGM may fail to converge to the solution for the VIP.
Solution to the VIP. Ẹ mọ̀ nǹkan tó ṣẹlẹ̀. A máa padà wá sí bíbá. I don't know if àwọn group àkọ́kọ́ tán ti ṣe bá àwọn tẹ̀ tí develop it up to this extent. We'll come back to this. Ẹ jẹ́ ká kọ́ lọ, ẹ jẹ́ ká tẹ̀ wo result yín ná. So from the result we can come back to have a máa pa because it's going to be a general reading, just like bá a ṣe ń ṣe iná ni general reading ní ẹ̀rẹ̀ wọ́n máa correct ẹ̀ line by line. I prefer that so that máa lè achieve nǹkan tó great.
All right.
Yes, sir. Dr. Ogunṣọlá ẹ̀ sọ̀rọ̀ àbí?
No, mi ò sọ̀rọ̀.
Okay. Dr. Aluko ẹ lọ lẹ́ẹ̀kan ẹ̀gbọ́n nǹkan tá à ń sọ mọ́ o.
Network ni. But mo ti get ẹ ní pé ká lọ sí main result pé a máa padà wá síbẹ̀ yẹn later. But our main result has been discussed earlier, abi?
No,
You haven't. Discuss it. Early better now.
Okay. So our main result, we have the following assumptions that we're going to look into in our main result. So from the assumption here one, the feasible set C is non-empty, closed and compact subset of the Rayleigh space H. The associated operator A as H map to H is the monotone, ellipses, and the sequentially weakened continuous on the bonded subset of H. So, and those are the conditions we're going to work on. And we also have the condition B being stated as the function of F, which is defined as FH mapping to H is contractive, as our rho is the element of 0, 1, and limit as n tends to infinity. So those are the condition of our B, as we can all see. So, star?
No, not you, sir. Sorry.
All right. And the following will be our algorithm.
Condition B.
Condition B, okay.
Sorry, B1. Condition B1. F from H to H is rho contractive. Say rho, is it in now? What rho is not an element. Rho is in the interval. But that interval now, is it going to start with 0? I don't think so. I think 0 is not inclusive. I don't know. Maybe I'm wrong. Because interval defined here is half open, half close. And
Yes.
I don't think that's the definition of contraction. Maybe it should be in the open interval.
Open interval.
Okay.
I don't know. Maybe. Just find out.
All right. Hello, sir.
Yes, sir.
Hello, sir. That P sample here was just like a we can take from one low P to be from 0, 1.
They are talking about if 0 is inclusive.
I know.
Because
that's what I'm saying. That have interval. I saw it in a book, in a material you sent to them.
Okay, correct.
I thought, yeah.
Yeah.
So that was why
So it's correct.
Okay.
So now we can go to your algorithm.
Yes.
I can delete and also just delete.
Delete.
Right. Delete it. So in his initialization, you got to initialize correct or wrong. Can you go to correct? So you call this one to correct for that initialization is wrong. Let X not in H be arbitrary. Wrong. Ẹ má bínú o, báyìí pé mo wà sọ̀rọ̀ pọ̀ lọ́dọ̀ títí ju àwọn alákọ̀ọ́kọ́ lọ. Bóyá mo wà inform lẹ́nu ni ẹ̀.
Bẹ́ẹ̀ ṣe ṣe lọ́dọ̀ tí a náà nù. Ọ̀dọ̀ tí
mo
wàá
rò
gan
pé
fẹ́.
èmi gan mọ̀ pé kò tó wáyé.
Kò tó lè rí o. Kò tó lè rí.
Ẹ ti gbàgbé tó ní ọjọ́ ti gorí ara wọn ni.
Ó yẹ sọ kí ló rọ́ǹgì ń bẹ̀. Bí mo ṣe máa láì kí n máa sọ ní anyway.
Okay.
Àwọn yòókù náà lè ràn yín lọ́wọ́ kó má dá yín dá bùkátà yín.
Ẹ má dá wa dá o.
Sir, can I come in there?
Please.
I think what is wrong there? Eh? Sir?
ẹ jẹ́ wọ́n rún kinní wọn náà.
Okay, sorry.
Inú
I'm going to generally. Sorry.
Wọ́n ti
sir.
sọ pé generally.
generally náà.
Generally. Má bínú, sir.
Ó yẹ sọ̀rọ̀ Dr. Ògúnṣọlá wọ́n béèrè generally ni.
Mo rò ní o, sir, pé ṣebí our n is a natural number.
Okay.
Hello, sir.
Yeah, I was calling.
So I think the sequence should be from x1. So my own the sequence xn should be from x1. You need to understand it, the money. Shouldn't be from x1.
Kò tí ì débẹ̀. Nǹkan tó ṣẹlẹ̀ ni pé àwọn míì ṣe mọ̀ pé Dr. Gafar máa mọ nǹkan tí mo fẹ́ sọ yẹn tí mo ti gbọ́ nínú program rí ní lórí Èkìtì tẹlifíṣàn ilẹ̀ kan mo ti gbọ́ mo láti gbọ́ lórí program rí. Àwọn kan ní nǹkan tí àkọ́ngbà táwọn kan bẹ̀rẹ̀ evolution of number ni pé àwọn mathematician kan wà kan include 0 as a natural number. Àwọn kan sọ pé rárá. Ṣé bí bẹ́ẹ̀ ni Dr. Gafar?
Bẹ́ẹ̀ni sà.
So but ìyẹn gangan kọ́ ni nǹkan tá a fẹ́ ó lè bẹ̀rẹ̀ láti 1 ẹ lè rẹ lómi tó pé sequence tí ó start ẹ̀ láti x1 ẹ lè rẹ lómi tó start sequence ẹ̀ láti x0 but nǹkan tó wrong níbẹ̀ ni wípé algorithm yìí inertial algorithm always have two initial points ni so ẹ lè bẹ̀rẹ̀ láti náà tẹ́ bá sọ pé x0 bá lè fẹ́ calculate un ẹ jẹ́ ká wò for instance kí ni u1 máa jẹ́ plus u1 ló máa nífẹ̀ẹ́ ní u-1 tá a bá fẹ́ calculate u1 kí lè fẹ́ bá lè ṣe máa get u1 you are going to have x0 plus tá a bá sọ pé u1 so yẹ kó jẹ́ x1 àbí plus alpha 1 into x1 into x1 minus x0 but x0 nìkan lè choose níbo lè x1 ti máa wá.
Wow.
Check get fine. So it should be x0 and x1 in H be arbitrary. So 2 points, the initial points, méjì lè gbọ́dọ̀ ní.
Wow.
Thank you.
Okay, ẹ jẹ́ àtẹ̀síwájú.
Àgbo ní tán lórílẹ̀.
Àmì o. Ọmọ kékeré ló ń kú.
Bẹ́ẹ̀ni.
Ẹ ń jíṣẹ́ wa wò.
Dr. Gafar ṣe ń gbọ́rọ̀.
Ṣé mo ní ká mọ̀ dá sílẹ̀ kan Dr. Ògúnṣọlá?
Dr. Ìwọlé ṣe ń gbọ́. Wọ́n là ń jíṣẹ́ àwọn wò.
Ṣé mo ní ká mọ̀ dá sílẹ̀ kan? Wọ́n ní general.
Mi ò ní dá sí mọ́ sí. Dr. Aluko mi ò ní dá sí mọ́ o.
Ẹ bá máa dá sí o.
Ó rà wọn pé lẹ́yìn yẹn kò sí nǹkan kan mọ́ mi bẹ̀rẹ̀.
Ọ̀gálẹ̀ correct, wọ́n ní yòókù correct.
Ẹ sábà wọlé pàtẹ́wọ́ fún wa.
Ẹ pàtẹ́wọ́ fúnra yín. Ẹ track.
Pé ìyẹn ẹni bí ẹni issue mẹ́rin for now. Ó yẹ jáwó lọ sálẹ̀ náà. Àyàfi pé kinní yìí kò align tó otherwise yẹn ṣe wá sá lọ síwájú tí.
Ok, òótọ́ ni wọ́n fi ṣe style ní sà. Style ni.
Otherwise yẹn kó dó sí.
Ìwà tí èsì Gàfárì lọ táìpù ẹ̀.
Àṣẹ yẹn wá fẹ́ mọ yọ sí Dr. Gafar. Dr. Gafar. Ẹ pa íńtánẹ́ẹ̀tì lọ́dọ̀ wọn.
Ẹja ṣàánú wọn. Nígbà mo ti ní èsè general ni wọ́n fẹ́ fi wọlé sí ńlá. Doctor.
Okay, so I think those ones are correct. So kò sí issue mẹ́rin. Indeed, it follows from 3.2, 3.3 and assumptions B2 and B3 that okay. Okay. So àwọn yẹn kò sí issue pẹ̀lú road mark 3.2. That is correct. Ó yẹ máa continue lọ. Ẹni tó bá ní question ẹ béèrè lọ́wọ́ wọn o.
Any questions so far?
No question. Continue.
Okay. Mr. Kajola, can you continue from here? Or Dr. Aluko? Okay, if there is no response, I think I have to continue. So, sir,
Ẹ
you
continue,
want to
sir.
come in?
Ẹ continue,
Ṣé
sir.
4.2 yẹn ṣé lẹ́ẹ̀ma 4.2 yẹn correct? Ẹ jẹ́ ká wò dáadáa. Irú nǹkan
Okay.
tá a complain
Náà pé
nípa
ẹ
títí.
correct tọ̀dọ̀ wá ń jọ yẹn.
Exactly, so ẹ jẹ́ ká tún
Ó
lọ.
likely kò mọ́ correct o.
Kí ló dé tẹ̀ ń fẹnu ya kalẹ̀? Ẹjọ́ gan kọ́kọ́ wò ná.
No, ṣe ẹ̀gbọ́n náà sọ́nsìn wọ́n ní ṣe
wọ́n
4.2
ti
correct.
wọ́n correct ẹ̀ last week but mi
Wọ́n
ìgbẹ́ wa
correct
take
wá ń jọ yẹn. Ibi tí yìí láti yọ ti wá. Mo fi ń sọ tí mo mí nìyẹn o. Dr.
All right, sir.
Ọlọ́nà, ẹ má jẹ́rú báyìí. Ẹ má jẹ́rú báyìí. You are doing well.
Thank you, sir.
Yes, sir.
ẹ jọ kí ni correction yẹn náà ká lè note ẹ̀ báyìí.
Wọ́n dà pé ọ̀gá tún fi nǹkan correct ìjọ wọ́n tún nǹkan kọ́njọ́ yẹn. Àdẹ̀lí ṣé àtọ̀dọ̀ wá ń sìn. Dr. Gaba. Dr. Gaba, sir. Dr. Gaba.
Mo wà pẹ̀lú yín, sir.
So ń jókòó ló.
Ẹ rẹ̀ pẹ́ padà sí correct. Ṣé ẹ nóòtì ẹ̀kọ́ ẹ̀rọ yẹn bẹ̀? Ṣé ẹ lè display tiwa ẹ lè ṣe àtọ̀dọ̀ wa? Àbí?
Ìyá mo sì ní manuscript yẹn. Ẹ jẹ́
Because wọ́n correct nǹkan nù lẹ́ẹ̀ma 4.2 yẹn. I can't remember vividly, but wọ́n ní bá ṣe position limit yẹn wrong or something else.
ó dàbí kíní ni àwa àṣìṣe tá a ṣe ń bẹ̀ ni pé a change àlòké àfiké síbi subsequent yẹn.
Okay.
Kéde
Ẹ
wa
jẹ́
mi
kí n
sọ
ṣe-
difference to wa.
ẹ jẹ́ kí n wo manuscript yẹn if there is any other thing. Mo wà pẹ̀lú yín o.
Ó dà pé 4.2 high yẹn tá a ti lo UNK substance UNK yẹn rà pé ní ẹ̀rọ yẹn wà.
Mo wà pẹ̀lú yín o. Mo dẹ̀ ṣe yín o.
Àbí Dr. Oyewole. Dr.
Rà wọ́n jáde.
Okay. Ìgbà ní báyà kẹjẹ kájẹ wọn continue bóyá tó máa fi débi tí ẹ̀rọ yẹn máa fi.
Ẹ má bínú mo ṣe mistake mute ni o. Mo wà pẹ̀lú yín.
Okay. Mo ní báyà kẹjẹ wọn continue débi kí wọ́n kàn wò káwọn aṣẹ díẹ̀ díẹ̀ bóbi tí ẹ ti get wá ń jọ yẹn máa padà get yẹn náà bẹ̀.
Okay.
So that ẹ jẹ́ pé formulation yẹn ń jọ yẹn ló ràn pé kankan pé báyà
Mm.
UN ni ò yẹ kó wà ń bẹ̀ something else ní òkè wà rántí but.
Ó dàbí syntax error náà mú níbi tọ̀dọ̀ tí wọ́n ń gbà yẹn. Ó dàbí syntax error ni.
Syntax score hypothesis yẹn I make complaint pa hypothesis but ẹ jẹ́ ká lọ náà ẹ jẹ́ ká máa wò lọ.
complain pa hypothesis yẹn pé bá a ṣe formulate ẹ̀. Kò
Ẹnìyẹn nìkan
alámọ̀-
kan look at the 4.1 itself. The 4.1 itself. Ìyẹn
Ìyẹn
náà
wrong,
wrong.
ìyẹn
Ṣé ẹ rántí
plus
pé mo
lẹ kó
sọ̀rọ̀
wà.
kan pa yẹn?
Plus lẹ kó wà
Minus
bẹ́ẹ̀.
yẹn plus ẹ̀ kó wà bẹ́ẹ̀ exactly. Plus
Plus
lẹ
lẹ
kó
kó
wà
wà.
bẹ́ẹ̀ yẹn.
Ìyẹn wrong, ìyẹn wrong.
Yẹ máa gbé lọ díẹ̀díẹ̀. A máa rí náà a máa padà rí. A padà rí there's something tó bá yẹ pé kẹ́kẹ́ correct me one. So by triangular inequality the equation B2 by condition B2 equation 4.1 becomes okay. by triangular infinity. This implies that Wn minus Ynk minus Unk. It will be by 4.3. How did it come about?
$4.3.
Okay, 4.2 losses 0, yes. Wnk minus. Nínú hypothesis here, for instance, here, hypothesis, the only thing to one hypothesis here is y. Can you clear now? I repeat here losses 0, yes. Then Ynk minus Unk níbo lòun ti wá. Ynk minus Unk o, kò sí nǹkan tó sọ pé òun lọ sí 0. Then Wnk minus Unk already ẹ ti sọ pé yẹn lọ sí 0 4.2. So mi ò mọ bó tó ṣe wà involved in 4.3. ẹ lọ tún kíní ìṣe o. Kò yé wa o. Bóyá lè explain fún wa, kò yé mi, for instance, kémi sọ èmi, kò yé mi.
Kò ní ìdí eré ìrìn ìdìmọ̀ nígbà yìí.
Kò need.
Because
Ṣé
ó ti wà ní 4.2 already. So, èrò kò rí ká
then
tó
okay,
kọ́.
4.4 ńkọ́? Báwo lẹ ṣe arrive at 4.4? Because 4.4 ń sìn, first part yẹn Wnk minus Ynk is already in the hypothesis. So but Ynk minus Unk, how did that come about? Bóyá, I don't know. Into yẹ kó wà mẹ́ẹ̀, 4.3 should be Ynk minus Unk is less or equal to méjèèjì left and right yẹn. Wnk minus this plus. Into yẹ kó wà ní left, òun ló wà right yẹn. Yeah. Into yẹ kó wà left yẹn, kí méjèèjì ti bí yẹn kó wà papọ̀ ní right. So if that is what you have done, then ìyẹn máa establish pé Ynk minus Unk náà lọ sí 0, which is fine. But the way you have presented it is wrong. Because
Okay,
they
sir.
invest in it.
I'm not
Into one
correct.
right here should be on the left side.
Bẹ́ẹ̀ sà, ilé
It's not about correcting it, it's about understanding what you're correcting.
ó ti yé sà.
Because it looks very, very wrong. Bush why? Like clear and got in chat láti achieve
Ó ti
4.2
yé.
already so loss is 0. Then
Right.
what about 4.3 again? And then 4.5, what's the essence of the 4.5? Now we show that Unk is quickly convergent to P in H. Ẹ má bínú o, ẹ máa sọ pé káwọn group 1 yẹn kọ́ fọ̀nà yín o. 4.7 náà, èrò gbogbo mistake táwọn náà ṣe ń bẹ̀rẹ̀ yín náà ṣe o. Kò sí nǹkan tí yẹn túmọ̀ sí o. Ó là pa sọ pé káwọn náà lọ reprove kinní yẹn ni. Àbí Dr. Ogunṣọlá báwo la ṣe sọ ọ̀tọ̀dọ̀ yín wà yẹn náà?
No,
Ó dé wò ní such a long time.
wọ́n kàn hard mọ́, kí wọ́n hard flesh mọ́ ni. But and if
Ó ti ti tọ̀dọ̀ yín because I'm 4.7 mo rántí pé irú nǹkan yìí ṣóun bí tọ̀dọ̀ yín náà.
No, ẹ mọ̀ tó ṣẹlẹ̀.
Mm.
Ẹ mọ̀ tó ṣẹlẹ̀. Mistake yẹn lẹ́sẹ̀ ọwọ́ mi gangan ló ti wá. I guess mo rò pé tán ṣe ni pé wọ́n try wọn ò fi bẹ́ẹ̀ ṣiṣẹ́ much ní under the nucleus yẹn. Wọ́n lọ hard flesh làwọn hard mọ́ skeleton ta fún wọn. Wọ́n believe pé ó ti correct. Ṣé pé mistake dẹ̀ wà bẹ́ẹ̀?
Yeah.
So mi ò lè blame wọn much. I want to believe everything is correct. Ṣé nígbà tẹ́
So,
máa wo tí wọ́n
first
tẹ̀lé
part,
fún àìpé ẹ̀rọ wà pé.
Yeah, first part yìí wrong. First part yẹn wrong. Any láti tún kíní ẹ̀ prove. Yeah, any láti tún rí eléyìí prove. Ẹ tún prove. From the second part.
It ma suggest ni pé jẹ́ gbọ́tà.
Okay, yeah.
I will suggest bóyá mo suggestion ni o. Bóyá tí a bá ṣe tán kí Dr. Gabao send iṣẹ́ wa sí orí wọn. Dr. Gabao ti correction yìí wọ́n ti ṣe.
Rather ká tó lọ báyẹn, I would prefer bóyá ká kúkú wò látọ̀dọ̀ wọn báyìí sìn. Let's look at it together. Ká wo títí tọ̀dọ̀ yín yẹn náà. Let's see bóyá a máa rí nǹkan tó yẹ ká correct tó yẹ ká ti correct bóyá tó wà ń bẹ̀. Tí Dr. Gafar bá lè share, I think Then from there they can see what they have done wrong and while they correct it. But I think from LA2, me sure come any problem establishing 2. But first, one and so on establishing wrong. From the group of things. Say Dr. Gafaru Simbi money.
Pẹ̀lú yín, mo ti send the correction yẹn sí group báyìí.
A fẹ́ kẹ́ share ní kí gbogbo wa tún máa wo again. Ká máa wo lọ báyìí náà. Ká wo náà.
Yeah. Ẹ jẹ́ kí n.
Àwọn máa gbé titi wọn láti ibi yẹn.
Ẹ jẹ́ kí n
But
try láti.
àwọn ti ṣe dé, wọ́n ti for example sí ṣá o. Though we have to continue to make the corrections. It's a nice September.
In the share.
Ẹni tó ń share stop o.
Okay. But I can share again. I can open it right. No.
Tàbí tó bá láti bẹ̀.
Bẹ́ẹ̀ mo ti
Orí
ń
fún mi.
open sir. Mo ti ń open sir.
Okay, ẹ ṣeun.
Àbá àwọn táìtù yìí gùn gan. Kí ló dé? Tẹ́sí ti gbọ́dọ̀ gò tó wáyé. Látọ̀ sọ pé pépà kan péré. Gbèsè details yẹn ti pọ̀ jù.
Sorry, Dr. Oyewole, ẹjọ́ mo ní suggestion kan ni. Wọ́n sì ń sọ pé gbogbo aná là ń partake ní iṣẹ́ group kọ̀ọ̀kan directly or indirectly. Kí ló tọ́ pé a ṣe kíní ẹ̀ papọ̀ so that a jẹ́ ọ̀tọ̀ níbi alákọ̀ọ́kọ́ àtẹlẹ́ kejì náà. So suggestion ni mo wò.
Ẹ máa ti pọ̀ jù. I don't know about other people, but lọ́dọ̀ sí àwọn fẹ́ kọjá mẹ́rin títí wa. Ẹ máa ti pọ̀ jù.
Bóyá bẹ́ẹ̀ ṣáájú èmi mọ̀ lérò pé àwọn ọjọ́ náà ó ní objection anyway, but ǹjẹ́ bá ti sọ náà ni.
Àwọn fẹ́ ju mẹ́rin lọ.
Tọ́nà ò lè ní objection náà, but ó depend lórí nǹkan tá a bá àgbì sí.
Ó ti pọ̀ jù lórí àwọn pépà ẹlẹ́wọ̀n á kó èèyàn bíi 6 èèyàn bíi 8 sí ó ti pọ̀ jù lédè láì ṣe biology.
Láì ṣe microbiology.
Àwọn ẹni wá kérò pé wọ́n á kó gbogbo ilé ayé sínú ìwà. Ẹ má wọrí, iṣẹ́ sì pọ̀ tẹ́ máa ṣe tẹ́ máa forúkọ sí. So there are still work that we do. Ẹ jẹ́ ká kọ́kọ́ tiẹ̀ get kalẹ̀ dúró náà. So ẹ kọ́kọ́ bẹ̀rẹ̀ pẹ̀lú kí lórúkọ hypothesis wọn náà. Hypothesis tí wọn náà sọ pé just like your sub proceeded. So the subsequent this SKG also converges weakly to P in each. Gbọ́dọ̀ àwọn kan fẹ́ show ni. So
Hello, sir.
yeah, our colleague.
Data mi tán ni o.
Okay. So using
Content sọmọ.
B2 4.1 equation 4.1. Now using B2 condition, that equation 4.1 becomes WKJ that by triangular inequality. The same mistake is still here too. Oh no, Lele, no again. The same mistake. Yeah. The same mistake, the same thing. So what about it?
Sport enjoy and you go export it. I thought you spotted that day. You spotted it that day.
Probably Miori. Because the same thing. Oh no, not the one B. Teba won't say 4.2 it already show pé kíní ẹ lọ sí 0. WKJ minus that. Now, let one low triangular inequality. Lórí interfere triangular inequality. The essence of using triangular inequality. Yeah. Only pé 4.3 yẹn ni pé left side yẹn la fẹ́ show pé gangan lọ sí 0. And we must already have that both two to add up yẹn méjèèjì yẹn ti wà until jẹ́ 0 already. You understand what I'm saying?
Okay.
Ká tó lè sọ pé left side yẹn lọ sí 0, a gbọ́dọ̀ ti establish pé méjì ta sọ pé add up sí left side yẹn gangan tó wà right yẹn àwọn méjì gan ti lọ sí 0 already. But if you look at that, left gangan ló ti lọ sí 0. And from the right, a ti rí pé alákọ̀ọ́kọ́ gan nínú hypothesis òun náà lọ sí 0. Internally, the kó lọ sí zero gangan is now the rightmost. Yeah, ìyẹn gangan la ní kó lọ sí zero. So it should have been ìyẹn kó wà on the left side. Kí méjèèjì ti bí yẹn come one right. Nǹkan tí ó bá correct ni.
Okay.
And by then 4.4 our conclusion will just be that.
Dr. Iwole.
Yes, sir. Yes, sir.
Moro, I think question 4.4 should come before question 4.3. Maybe 4.2 should be expunged totally.
No. It's correct, Boshewai, except that the 4.3 needs to be restructured. Conclusion that I make again is the 4.4. Our conclusion itself wrong. Into correct ni pé, let me write it. Stop sharing. Let me write that. I'm going to be legible now. Frank, we write to Dr. Mokokolu and Alabere. Now, only this is triangular inequality. A is less than or equal to B plus C. Because I'm going triangular inequality. I'm really no. Let's show limit from really, for instance. Now, if the limit of this guy goes to 0, the limit of this guy goes to 0, then automatically the limit of this one too will go to 0. Now, in your own context, you have already established where, for instance, Wn minus Xn will lose 0. Nino hypothesis, it's already y n minus something, that's yn minus wn, yeah, we know it loss 0. I have to show yn minus xn now loss 0. I have to show loss 0. This is what you have. Now, you can use the triangular inequality to say yn minus xn is less than or equal to wn minus xn plus yn minus wn. So now, since tele loss 0, it implies this guy will also go to 0. Yn minus xn will also goes to 0. So this is supposed to be 4.4. Now, LA intercoco proof ni LA wa part of the hypothesis. This is the hypothesis. Now, there's a proof LA loss 0, LA no loss 0. So you can conclude that this also goes to 0.
Oh.
So it's clear, right?
Yes, very clear. Very clear. Very clear.
You mistake carry through, so don't you carry through. So 4.4, yeah. The only thing they need in 4.4 is just the right part, the second inequality. 4.4, I'm talking about 4.4, not 4.3. 4.4, the only thing they need is just the limit of ykj minus skj plus 0. And now from 4.4, it then suffices to say that since the subsequent wkj is convergent, the subsequent skj is equally convergent. Now that would be wrong. That would be wrong because in 4.4, because I conclude in 4. Only correct variant. Only correct. But could you get 4.4 nìkan? So if we first 4.4, reason is WKJ, let's suppose we're convergent, right?
Yes.
But first part of WKJ yet to show we YIKJ now conversing to WKJ conversing. Abi?
Yes.
So consequence of that, YKJ minus SKJ now ma padà sọ fún wa wípé SKJ náà lọ sí the same thing.
Yes.
Mi ò bọ̀rọ̀ yẹn clear.
Okay.
So I think Auto lots of it because Auto already include WKJ minus YKJ. Yeah, Auto. The statement is correct. Yeah, Auto. The statement is correct. So, but equally convergent to what? Because convergent here, sorry, so converge sikini. So general. You have to be specific. Since this guy converge so then converse the same thing. But because we equally convergent. Converge equally convergent. Most of WKJ converse P. Then equally convergent. So not converse Q. But the P and Q has to be the same thing.
Oh, yes.
Òun ló fi lè fún wa ní 0. Ṣé you understand báyẹn?
All right.
Now, ẹ wá sọ
I
pé
think
ẹ tún wá sọ pé now we show that SKJ is weakly covariant to P in H. But why? How?
that's a mistake. It's a crash.
Okay.
Tautology ni ẹ má bínú. A máa respond yẹn fún bẹ́ẹ̀.
Yeah, me sure when you are required. So 4.7 years, the bala will no the same thing. So ó dà pé mo sọ pé mo máa sọ̀rọ̀ kan lórí ẹ̀. Bóyá yẹn ni mi ò rántí wọn. But I think 4.2, just like I said, I'll be 2. The second part of the hypothesis, a padà wò yẹn. I sọ pé first part, and we have to do something about it. So, but the way it is now, at least up until 4.4 and the conclusion that follows, yeah, correct. We can be sure that that is correct. But in totally, before we start 2, I don't think that one is required or it's correct. So we can go and think about that part. So let's be now we show that FKJ is weakly covariant to P in H up until P in H. Conclusion TTT. So we have to go and check again. Why do we need that? Of what essence? And 2, I think we can go to 2. I'll try that with 2 now. Imagine with 2. Ọjọ́ ti lọ. Torí ẹ̀yin tẹ́ ń lọ sí ilé ìjọsìn. Yeah, ẹja ká parí síbí. So ẹ ti mọ̀ pé nǹkan kan náà lẹ́yìn méjèèjì jọ wà báyìí. Àti group 1 àti group 2. You have the same situation there. You have to go and solve. The same thing. You see difference in nǹkan tẹ́yìn ṣe àti táwọn náà ṣe you have the same thing there. So go and see, go and check what is the essence of proving 1 get itself, the hypothesis. I think 2 will be correct, but in the essence, what's the reason for proving that 1? It's item méjì ló wà nínú hypothesis lemma 4.2 yẹn. 1 and 2. Kí ni reason they should prove 1 gangan? Try and get the essence of proving 1. So ẹ jẹ́ ká gbé láti bí bẹ̀rẹ̀ next week. Ẹ má bínú tó bá yẹ pé our hard on ẹ̀yin
No, that's how it should be.
group 2.
We are learning. No.
Yes, sir.
Thank you very much.
Thank you very much.
Group 1, well done. Oh.
Thank you. All right, thank you.
All right, so.
Alaikum assalam. I'm unable to stop my system, Yuma.
Borí pé ẹ ti bí sísà, ẹ tí bá mi check iṣẹ́ wọn.
Mo busy lóòótọ́. Well, my check ẹ lẹ́nu.
Nǹkan mọ̀ bẹ́ẹ̀ tí mo ṣe mo wà on the right path ní sà, bẹ́ẹ̀ máa kí n.
Yeah, I will check it today.
All right.